let's take a look at it. What do we know? What's all the information they've given us?
The graph.
They've told us that we're looking at a graph, okay, and that we're looking at its tangent line, right? So that means that everything in this particular question is going to be based off of that equation, right? That means we're going to need a point and a slope, and so that we're looking at for a point and a slope. But we don't actually know what the slope of the line is supposed to be, except that they give us this little piece right there. That the tangent line is supposed to be parallel to that line. So what do you know about that?
Same slope.
Got to have your same slope. So what's the slope of this line? You have to find it. Now I saw a couple people, remember, how much time you got on these questions? So you got 2 minutes tops, and these are supposed to be the fast questions, right? These are the ones that you don't want to take much more than like 30 seconds on. So taking a look at this thing, if it says it's parallel, so a lot of people go all the way down to y equals mx plus b. Can you look at that and tell me what the slope of the line is? It's got to be 1/2. Why? You subtract the 2x, you divide by the -4. I don't care what happens to that 3/4. Who cares? That's going to be, you know what your slope is here, your m is 1/2. Well, that's a slope of this. So what do I have to do over here? Take the derivative. So what's the derivative of 1/2 x to the 1 squared? Y prime is x, and set that equal to, you know what your x is. It's got to be 1/2. Now the question becomes, what is your y? If we take y and evaluate it when x is 1/2, you would get 1. Blam. Want to talk about the next two here? Just go ahead and start talking about them all. Y'all want to give you all a chance if you want. You want to take those on? A couple people got hung up. You want to take them on, or are we just going to talk about them? It's your choice.
Take it on.
Take it on! All right. Take it on. Go beat it. Yes. Destroy. 0-3. Now, talking about that, how many people got caught up in what the whole question was even trying to say? That's probably the hardest part. Obviously what it wants is, eventually we're going to use this x equals 0.12. But we're actually finding an approximate value. In calculus, that means we're going to use a line in some nature. Whether it's going to be a single line in a linear approximation, or have this been, say, not x equals 1.2, but like x equals 5, would a linear approximation would have made sense here?
No.
No, at that point we probably would have used an Euler approximation over at least 5 steps. All right, because no one ever wants to do more than 5 steps in an Euler approximation, let's face it. Okay? But in this case, we're looking at, because it's really close, we're going to go. Now, what you hopefully realized is that there's no way you're going to plug 0.12 into this and actually get an answer that you're going to be able to solve. First off, the sign of 1.2, who knows what that is, right? On top, and then, once you get some creepy looking decimal here, then you're going to take the square root of that. Okay? As they said many years ago in an ancient and old meme, ain't nobody got time for that. Oh, he went there. That's right, I am hip with the children's, yo. Alright, so what do they want us to do? Well, I can't do 0.12, but I can do x equals 0. 0 is easy. What is y when it's evaluated at 0?
2.
It's 2. Yeah, I got this. A little bit harder is y prime of x. We need to find the slope, so how do you find the derivative of x here? It's going to be 1/2 4 plus the sine of x to the negative 1/2 times cosine.
No.
Like there's a cosine of x. Not to see the prime. All right, and then we're going to evaluate x prime, y prime at 0, and when we calculate that out, and we substitute in the 0, you hopefully got 1/4. Now, again, like I said, I'm one of those people that halfway through a problem, I do all the math, all the calculus correct, and then I get to the very end and I go to plug in a number, and then I forget that there's a negative in the exponent, or I forget that there's a negative in the problem, and I completely goof it up. So be careful when you're watching out, plugging in those numbers. But once you get that, now we have a line. Now we have what? Y equals 1/4 x plus 2. You're like, wait, what? Y minus 2 equals 1/4 of x minus 1, or x minus 0, right? You're like, yeah, we got that, yo. Now can we plug in point 12 here? Yeah. What's 1/4 of point 12? Now we've got an answer that we can solve. Is it correct? Hey, probably not, It's obviously an over and under approximation, but it's fairly close to 0, so it should be close to the actual answer. We're going to look at the harder of the multiple choices on this. We want to jump over to 16 because I want to make sure I give us plenty of time to take a look at this. Now, before we get too far into this, I will tell you that this is the 1996 test. What that tells me is that in 96, there was a much heavier, just looking at the test, there was a very heavy focus on algebra manipulations and integrating your algebra with your calculus. They have slightly moved away from that. They want to test if you know calculus. They don't really care as heavily on your algebra skills. Does that mean that you can be weak at algebra? No, of course not. You still need to have those algebra skills. Well, this is an old question, and I wouldn't expect to see one of these on a problem really nowadays. I wouldn't expect to see it. Could they change their minds and totally decide to be like, yo, I want to throw this one back up there? Sure. And just because it's old doesn't mean that it's not good. Well, how many of you are interested in going into computer science, engineering, sciences, mathematics? You don't take calculus BC if your entire goal in life is to become a Nordic poet. Okay? At least not most of you, okay? I might have had 1 or 2 students who have threatened me that they were just going to do Scandinavian poetry after taking calculus BC. They're like, it's easier to write things about Thor. Yeah. So, they give you this beautiful picture. You've got a tangent line L going through off of point Q to this graph y equals x minus x squared over 500. And the first thing they want you to find is the x-coordinate of the point Q. This is where you have that unique kind of brain melding type of question. They don't ask ones like this very often anymore. But if we can bring ourselves to start thinking of unique ways to solving this, you know that you're heading towards that right path. Fact is the higher up in calculus you get, the less calculus you seem to be doing and the more algebra you'll do. In Calculus 4, differential equations at my college, we had questions where it was, here's the problem, 2 lines of calculus, 5 pages of algebra, because of initial conditions. So you have to get used to that. So, how are we going, and just kind of ponder, give ideas to each other, throw ideas up to me. What things can we do? Yeah, no, not throw things at me. But how are we going to find this x-coordinate at point Q?
The derivative.
Take the derivative of the function of x. We can do that. Y prime is equal to what?
1
minus x over 250. Beautiful. Now how the heck is that going to help me? We've got a derivative.
You have a point on the same line.
We have a point on the same line. So how is that going to assist me?
You can make a tangent line.
I can make a tangent line and I can use, well, I can't quite use point slope here. And let's talk about that. We can't use point slope because I need to know what the slope of that line actually is. But can I plug 0.20 into the derivative function in order to find the slope of the line? We can't? We can't because it's 0.20 even on the curve. So 0.20 is not even on this derivative, so we can't use 0.20 to find the slope. This is where we run out the door screaming. So what do we do? I will tell you that you are right that we have to utilize this point Q and this other point. The question is, what is the ordered pair for Q? And you're going, well, that's a good question since we're looking for the x value and we don't know it. But we kind of do. Kind of, sort of. What could I write for the point at this stage? Do we know what the x value is? Where you say, of course not, that's what we're trying to find. Stop asking a stupid question. But there's a point to that, so what are we going to call that point?
Q.
We can call it Q. We can call it X. That is point X, do you all agree?
Yeah.
You're all like, okay, that seems kind of fruitless. What am I going to call the Y coordinate? We could call it Y, which is, but since we're looking for X, shouldn't we give Y in the context of X? I agree, it's X minus X squared over 500. Can I use that to my advantage in this problem? Can I use the combination of these 2 points to help me? We can do what? We can use the slope equation thing. Yeah, we can use the slope, which is the change in y over the change in x, isn't it? So what would we call that? We'd call that x minus x squared over 500 minus 20 over x. And what do you know about the slope of line L compared to the instantaneous rate of change of y at the point Q? Those two things are equal to each other. Your job is to set 1 minus x over 250 equal to x minus x squared over 500 minus 20 over x equal to each other. Now that is disgusting and terrible and horrible, and yes, they're going to expect you to solve this. And you're going, I don't want to do it, it scares me. It shouldn't be too bad. So how would you solve that? Just real quick, see if you can come up with that. I'm going to let you take the time to go through the steps. I'm only going to give you a couple minutes. Your answer should actually come out to x equals 100. See if you can get to that answer of x equals 100 in this problem. All right? Those algebra manipulation skills are going to be useful. Some of you have already started doing that. That's awesome. Beautiful. Beautiful. Love what I'm seeing. Love what I'm seeing. You. Remember, I'm a big believer in the concept of KISS, K-I-S-S. You've never heard of KISS? You really need to live by that motto. Keep it simple. The S can stand for any type of adjective that starts with S that you want to refer to yourself as.
Smart.
Keep it simple, Smarty.
Oh, yeah.
Sorry about that. I will say, don't try to do this as a quadratic formula type, factor thing. That's going to be way too hard. The first thing I notice is that I've got x's on both sides of my equal sign. Start crossing stuff off. Zeros and eliminations are your friend. Do not miss those. The other thing I'm going to notice is that I can move the 20 over here and the positive, the x squared over 250. Well, x squared over 250 is really 2x squared over 500, isn't it? So when I get to the next step, I should really get 20 equals 2x squared over 500 minus 1x squared over 500. Better be. I saw a lot of you get stuck at that stage where you're trying to put together those fractions. You're like, I don't want to put together fractions. That's hard, especially at, what time is it? About 10:30?
Too early.
Yeah, too early in the morning. But, look, these are simple fractions. And if you'll notice, this is a non-calculator, so you'd have to be able to do that Multiply by 500 to get 10,000 equals x squared, which when you take the square root gives you technically two answers, but I'm really hoping you can believe me that it's not negative 100. Just saying, you know, got to be logical with that. So you got x equals 100 feet. I should probably put the unit there. It's important stuff. None too shabby?
No.
Nah, that's not too bad. Now, once you've done A, you've done a lot of that dirty work, okay? Going through the next part, they need you to write a linear, an equation for line L. What ordered pair are you going to use for line L? I'm going to use 0, 20. I'm not going to go find this x minus x squared over 500 and use 100 for that. That's crazy. I'm going to use the point 0, 20. Now I do have to find the slope of the line. Do you want to plug it into your ridiculously crazy m, or do you want to just plug it into y prime? Obviously we want y prime. 1 minus 100 over 250, which is 2/5, which brings us to our slope being 3/5. 1 minus 2/5 better be 3/5. You get y equals 3/5 x plus 20. And you're golden and wonderful and amazing. Those are the theory questions. Then they give you the ridiculously stupid application question that makes no sense in the world whatsoever. Because apparently we have a hill that looks exactly like a parabola. Go figure. Now I have this image of this like civil engineer trying to build a perfect parabolic hill. And on this particular hill, there is a 50-foot tall tree growing perfectly vertically exactly at the highest point on the hill. So we found out that whoever built this hill is ridiculous. That's what we know. And then they've decided that they want to put a spotlight that for some reason is apparently shining up the hill at point P for no apparent reason and trying to hit this tree. And the question becomes, is the spotlight even worth trying to hit the tree? Are we going to hit the tree or not? So what would you have to do in this particular case? What are all the things that we'd have to take into consideration? The what? We have to find the midpoint of this particular shape. Now, this is a calculus class, and sometimes there are some things that they're really picky on that you have to show the calculus for, and sometimes they're not very picky. The midpoint of this, hopefully they would understand that, hey, this starts at 0 and goes to 500, you can use x equals 250. And I would assume that that would be an okay version. Let's say we had to use calculus to decide where that relative maximum, in this particular case, an absolute maximum, if we've got that domain, where would this maximum occur? How would we solve that using calculus? We take the first derivative and we set it equal to y prime, which is 1 minus 250, x over 250, which equals 0. And of course, when we do a whole bunch of math, we get x equals 250. Which, did we know that? So all we're doing here is we're just covering our butts, and we're showing them, hey, I'm using calculus. Look at me, I'm special. Okay? And that just, again, it's kind of just saving your skin, making sure that you're good. Because what if this didn't go through 0? What if they didn't tell you where this other root is? That might have made the problem a little more difficult. So we used our calculus. We found the midpoint. Great. What are we going to do with it?
Plug that into the tangent line to see what the y value is at that point.
All right. So we plug it into the tangent line. We get y equals 3/5 times 250 plus 20. Boom. That gives us $1.75. So we know at that point the light is hitting, and remember that this is the light. I like to label things. I was also a physics student, so labeling things is good. Okay, we've got the light. The light at that spot is 175 feet in the air. What else do we have to find?
The y value and
Find the y value of that particular hill. So we're like, yo, okay, we can do that. So the next one we're going to get y equals 250 minus 250 squared over 500, and we're like, wow, that's kind of a pain in the butt. Why would they do that to me? But when you go through and you calculate it without your calculator, you get 125. Thank you. Okay. Anybody catch it? What have we not included yet?
Yeah.
The height of the tree.
Yeah. Or sorry, this is not 175. That's 170. My brain just totally farted on me. I apologize. I was answering the wrong part. This is 125, but add the 50, and you find out that the tree is
75.
175 feet. Will the light hit the tree?
Yes.
Certainly. It only shows the top 5 feet of the tree, so I don't see how that's useful at all. It's like, hey, look, it's the top of the tree up there. Good. But we can see the top of the tree. Why do we want to see it? Maybe someone made a cool design. I don't know. Now, of course, what do you think the danger in this question is? What do you think a lot of people get really caught up in? They get to the 125 and they'll just say, no. So be careful of that. It's not too bad of a question. Other than the fact that how many of you are like, I'm so glad that they don't ask us to do much of this stupid stuff anymore. All right. Let us take a look at the multiple choice question. How are we looking for time, folks? I rely on you all. Got 20 minutes? Oh, good. We're sitting pretty. We're doing fine. Look at that. All right. Let's take a look at question number. Holy moly, all my things are out of order.
Hey.
Oh, yeah.
I feel like it's forever.
Let's rock out question number 10 and 13 on the multiple choice. These will be the last two multiple choices you will probably take a look at. And then 13, the top and the bottom question. Me doing a nothing sandwich. I'm not doing anything in the middle. The natural log of xy equals x. 1 over xy times. Equals? 1. Rudy. It's not horrible. We can deal with that. The other thing we're going to have to do before we get too far into this function, obviously if we're looking for the slope of the line, we should probably figure out what the y is going to be. So when we figure all this out, we know what the x is. The x is 1. We get the natural log of y equals 1. So y has to equal e. So we can do a bunch of stuff, and how do I want to do this? I'll do it this way. What is that? X dy dx equal to xy minus y over x. So you substitute all that stuff in, you get e minus e over 1, which is 0. And of course, we recently taught you L'Hopital's rule, so anytime you get a 0 or infinity in any question, you're all now doubting yourselves. Am I right? You're like, I have a 0. Wait, is that an indeterminate form? Oh God, this is most certainly allowed. 0 over 0, infinity over infinity. Those are the two you're not allowed to have. If you get 0 times infinity, you can modify that to get one of those. Your answer should be 0. Hey, I left the answer up here. Cool. For number 13, apparently I left it on the board. My apologies. But the whole purpose of that was to set your derivatives equal to one another, which was not actually... By the way, have you all enjoyed the fact that you went from Algebra 2 hating E completely, like you thought it was the worst thing to ever be invented, and now you don't get more excited than when you get E in the problem? The derivative of E, I've got that. Stand back, I know what e to the x is. So that was hopefully pretty straightforward, and then you set these... One thing I do want to point out though, I've seen people make this mistake a million times on a question like number 13. They will go through, and they will start doing e to the 2x is equal to 3x squared, so then 2x is equal to the natural log of 3x squared, and divide that, and they will go through, and they will try to find what that x is supposed to be, and it makes me want to cry. Don't do that. That's not fun. Okay? You don't have time for that. You don't have time to try to manipulate an equation for that. What are you doing once you get down to this stage? You're going to take a graphical analysis, you're going to plug it in, and you're going to utilize the intersect function on your calculators. Okay? And that is what you're going to do when you go through these problems. We groovy? Peach king even. All right, we're going to do the next two free responses. We're going to knock out the free responses because I actually like these. These are pretty nifty. All right. 15, a little different than what you're typically given. Trust me, as teachers, we hate creating these questions as much as you hate doing these questions because creating tables in Word or Excel or whatever we're working on is terribly annoying. All right, and then you have to calculate the values, and it's just not cool. But either way, if any of you want to go into the sciences or engineering, you're going to look at a lot of tables. You're going to have to be able to do this. We're going to let f be some real function differentiable for all real numbers. That's important. We like that. Just means the derivative exists over everything, so that's always happy. They give us the table above with all the values. They tell us it's over a closed interval. They tell us the second derivative has a property that double prime of x is greater than 0 over those two from the same exact interval. And we are asked a 3-point question. Number 1, write the equation of a tangent line to graph f at the point where x equals 1. If you miss this, your teachers will hunt you down and wind up going all Freddy Krueger on you. It's like, oh, that's scary. That's right. That's what it's supposed to be. Why is this first part supposed to be such an easy question?
We give you everything you need.
Because it's all right there. Boom. So, what's our equation?
Y equals 5 to x minus 1 plus 1.
Holy mackerel, you've got that beautiful. By the way, that should be, because that's part of the question, that should be 1 point. Part number 2. Use this line to approximate the value of f of 1.2. So, we do that, we do some math. You are going to get what? -3. Now be careful how you're going to write this. How are you going to write this? You're going to say f of 1.2 is approximately. Make sure that you're squiggly. If you are a small squiggler, squiggle larger. Because if it even kind of sort of looks like equal signs, they're going to wind up beating you. And what we got is approximately equal to 5 times. I enjoy making sure that they know that I'm plugging in the number. That's a good first step. And then you get your -3. All right, you're awesome. And finally, is this an over and under approximation?
It's concave up.
How do you know it's a concave up function? Because it tells you that f double prime is greater than 0. So when you go and you defend your answer, your reasoning, how are you going to state that?
Since f double prime that's 0.
F double prime of x is greater than 0. And I would put on 1.5 to 1.5. I'm going to make sure to state that this is the rate. Why is it important to give that it's greater than 0 here? And give the range, or domain of the question.
Because they might assume that you're talking about the entire.
Yeah, I only know this is greater than 0 for this particular domain value, so I've got to incorporate that. Since this, I'll put then f of x is concave up. And then just make sure that you include, I'm going to say which makes our answer in under approximation. Again, notice when we're going through that, I included the f double prime was greater than 0. I included the domain that they've stated. I included that it's concave up. I've told them that it's an under approximation. It took a lot of stuff. That's we've got 5 minutes left together. Don't forget to let me tell you my joke at the end. It's pretty funny. All right, so we want to make sure to include all of that to do that. Could I have answered that question if they would not have stated that? If this was omitted, could I have answered that question with what I was given?
Yeah.
Yeah.
No,
No.
because you don't know what's happening until
Exactly. We have to be careful with that. I only know what's happening at these values exactly. What if between 1 and 1.5 the graph looks like this? You know, between 1 and 1.5 it looks like this. Well, what if this happens to look like this? I don't know what it's doing. They didn't tell me. So you have to be careful that only use the information that they provided you through there. There's only one more left. I do want to make a statement here because I've had people tell me this in the past and it drives me absolutely nuts. On the AP test, if they give you a question like this, and they say, show that dy dx is equal to y over 2x minus 1, if you get a different answer, do not inform the AP grader that they are wrong. Because I have written tests where people have went, I got a different answer, so you're wrong. And I respond with, no, I'm not dealing with it. And that's an easy set of points to be able to get that out. The other thing I do want to point out, if you're doing this, you do want to show a couple manipulation techniques going between there. You know, when you get your 2y dy dx equals what? X dy dx plus x. And when you get to that, you do want to show at least the next step that you've got your 2y minus x dy dx over here like that. And then you can assume that. You want to show at least one in-between step so that they know that you know what you're doing in a problem like that. The last one that I do want to just point out real quick, this is not hard on this particular problem, but in this very last piece, when you get to a question like this and it says show that there's no point where it's horizontal, what are they trying to get you to realize? How would you prove that it's not horizontal?
Zero.
Yeah, when you go to this and you get your y over, what was it, 2x plus what? 2x, 2y minus x, thank you very much. They want you to set that equal to 0, correct? And when you go and solve that, you can easily show that y should equal what? Yeah, y better equal 0, right? But then when you go back to your original function and you plug in the 0 for the y, what do you wind up getting? You get a beautiful 0 equals. Does that make any sense? Of course not. Okay, ready for a bad joke? You got 2 minutes. Okay, you ready? You're one of my kids. Wait a minute. Messed it up already. What is the integral of 1 over cat and decatur?
Wow.
You're wrong. It's a houseboat. You forgot C. Alright, ladies and gentlemen, there's 1 minute left. Thank you very much for your time. You have been a wonderful group.